Hello students, with continuation of model 2, we are going to discuss that is the transient heat conduction. First, understand what is meant by transient heat conduction. So transient heat conduction is nothing but unsteady state heat conduction, which is time dependent conduction. In case of steady state, there is no depend upon time. Okay, so but here time dependent conduction of heat transfer is taking place. So this temperature is inside the conducting body that immersed in suddenly in a bath of the fluid at a different temperature. Example, quenching of special alloys or heat treatment of bearings. I'll elaborate this example. Suppose if a hot ball were immersed in a cool pan of water, the lumped heat capacity method of analysis might be used if we could justify an assumption of uniform ball temperature during the cooling process. Okay. Clearly, the temperature distribution in the ball would depend on the thermal conductivity of the ball material and the heat transfer condition from the surface of the ball to the surrounding fluid. So we should obtain the reasonably uniform temperature distribution in a ball if the resistance of the heat transfer by conduction were small compared with the convection resistance at the surface, so that the major temperature of the gradient would occur through the fluid layer at the surface. The lumped heat capacity analysis then is one that assumes that the internal resistance of the body is negligible is comparison with the external resistance. So the convection heat loss from the body is evidenced as decrease in internal energy of the body as shown in the figure. Okay, so here you can see the copper ball with uniform temperature. Okay, but irregular shape of the body, it may have not uniform temperature. So here T of x, y, z and T is equal to T of T. This is that example for lumped capacitance model throughout the body. So this temperature is essentially uniform throughout the body if you are analyzing the lumped parameter analysis. Okay. So what we have to do is for the hot forging that is initially is at uniform temperature Ti, it is suddenly quenched immersing in a liquid of lower temperature, that is T infinity is less than Ti. So then what happened at 0 second, T is equal to 0, then temperature T becomes Ti. So the body which is immersed, the temperature is Ti and the liquid temperature is T infinity. Now we can write the small change in heat, that is delta Q is equal to dE by dt. So by energy balancing equation we can write energy in minus energy out plus internal heat generation is equal to total energy stored. So this is how we can analyze the problem by taking the energy balance. Okay, so for the lumped mass capacity model, so we can write by convection, we know that the equation minus HA T minus T infinity and rho V Cp into dt by dt. Okay, so by modifying this equation or substituting the values, so then what happens, the temperature distribution we can write it as T minus T infinity divided by Ti minus T infinity is equal to e to the power of minus T by T, where T is rho V Cp divided by HA. Okay, so that is RT into CT, where R is resistance to convection heat transfer and CT is a lumped thermal capacitance for the solid. So if it is the case, so we have to write the lumped parameter analysis, the equation, final equation, it becomes, for that there is T minus T infinity divided by T naught minus T infinity is equal to e to the power of minus HA rho CV into T. That equation also we can modify it later with a dimensionless number that is that is Bayat number as well as Fourier number. So what is Bayat number? Bayat number is HL by K. But in this case, if you consider L is a characteristics length, so that you have to consider. So H delta T by K delta T LC we can write. So if you write this one, so it becomes what? So convective at the surface of the body to the conduction within the body. So this is the ratio of this ratio we called as Bayat number. So if the Bayat number less than 0.1, so we consider as that system is a lumped system. Okay, so based on this you may get some problems to solve this. Okay, thanks for watching this video.